That's equal to 3 times 3 times 3. 1, 2, 3. And the base is always 3. Right? And this is equal to 27. You can do it in your head right now. And you have your multiplication chart. 3 times 3 is a 9. Times another 3 is 27. What if, so that's number 2. Side note. What if you have a negative 3 at the base? This is going to be the first thing today that we do with negative numbers. If I'm talking about the third power of negative 3, I need to use the parentheses. That's some terminology again. Third power, I always say cubed. That's 3 cubed. And that's 3 squared, if the exponent is a 2. How about this one? Same thing, but instead of a 3 here, I have a negative 3. Negative 3. The cube of negative 3 is this. So what about this? What is negative 3 times negative 3? I'm multiplying two negative numbers. The result is a positive number. So that's what comes out. Times a negative 3.
Which is -27.
Negative 27.
Negative 27.
So the third power of negative 3 is negative 7. How about this? Just a side note. Negative 3 squared. What do you think it could be?
6. I mean 9.
Yeah, positive number. Again, the base is negative 3. I'm going to multiply it by itself twice. Then it's two negative numbers getting multiplied. The result is positive number without the negative sign. Yeah. All right, so that's 3 cubed. So let's put it down so I know something. It is asking you to evaluate. You need to come up with a number. So x cubed, third power I use cube, second power I use square. X cubed minus 8y plus 1, right? That's what I need to do. My x is 3, so this part is 27.
How do we know that the x is... Oh, because I see it. X equals 3.
The second part, it's giving you an expression, as it's called, the x cubed part here.
Right.
But it has variables in it, x, y, z, whatever. And the numbers that you need to use in place of them, 3 for x, 5 for y. So 8y, I'm not going to forget about the minus sign or negative sign. 8y is 8 times 5. Your chart, you know it, that's a 40. So 27 minus 40 plus 1. Okay. We don't have any parentheses here, right? So you may be thinking, just think about it. If it's not an irrelevant question, if it doesn't bug you, you can ignore what I'm saying. Is this telling me that, what is 40 plus 1?
40 plus 1 is 41.
Is that what it's asking you to do?
No.
Or 27 minus 40 would be first 27 minus 40. But one way that I heard from folks like you,
Negative 13.
negative 30. So negative 30. You start with 27, but you start with minus 40 means move to the left 40 units. Right? After 27 units, I'm at 0. I have to keep going 13 more. So that all together, I have a 40, and that's my minus part, moving to the left. If I go 13 units to the left of 0, negative 30. So that becomes, it's not this, so negative 13 plus 1. Okay, negative 13 plus 1.
Is negative 12.
Yep. Plus means move to the right, and 1 unit. I get closer to 0, it becomes less negative. Negative to the right. Now, for this, we will see other rules, which operations you do first, what's the convention when there are no parentheses. Of course, if there are parentheses, you go with parentheses. If there aren't any parentheses, and if you have a bunch of additions and subtractions in a row, what's the rule? Left to right. Left to right. Left, and then include the right. Because it would be different if you had done this, what would the result be? It would be negative 14. You go from left to right. If you have a bunch of additions and subtractions, it's left to right. So if I didn't mess it up, this should be negative 12. Okay, how about this one? This is something about this week, truly about this week. Negative 19 plus negative 16, negative 16 inside the parentheses. So this is the same as, this operation is the same as negative 19 minus 16, really. It's as simple as that. So that's negative 19 plus negative 16. I don't have space over there, so that's negative 19 minus 16. I have no idea why. Sometimes people find this confusing. Negative 35. This negative 16 means I'm going to take the number and
add
move
it.
16 units to the left.
Mm-hmm.
That's what it means. So,
Negative 35.
negative 35. So that's why 0. That's why negative 16. And one way to think about it again, put the negative sign out and start the parentheses. You know? So minus, and that 19, minus minus plus 16. What is this? 35, but you have to include the negative sign.
I use the keep change opposite thing for the.
Guy, you have that kind of stuff, all kinds of keep
But it
what?
makes it easier though.
Okay,
Yeah.
as long as it works. As long as, what is it again?
Keep change opposite, so like you keep the negative 19, right, and then you change the middle sign, so if it's negative, you add it to, you make a plus sign, and then you do the opposite of whatever the next number is. So if the next number is positive, you do a negative, and then you always add two negative numbers. And that's how you get an answer. You know what I'm saying? You know what I'm saying?
You look
I
confused.
know. I know.
I'm getting too old
Okay,
for
all right.
this. No, it's amazing.
I'm from Turkey, by the way. I came here for grad school. I didn't even go to high school or middle school or even college.
Oh, wow,
For
okay.
grad school.
You don't know
This-
what I'm talking
So, I kind of got it.
about. Okay.
Keep, change, opposite,
Yeah, I don't know why it works, but it just always
As long
does
as
like
it,
that.
as long as it works.
As long as you get the right answer.
For real. Also, you know how you changed the last test, to be longer and you can see the time? I think you're gonna have to do that for each test. Cause this doesn't it still
Okay.
doesn't show me, I don't know, you don't have to do it right now, cause I know your time, but just to let you know.
Okay.
You want me to write it down?
Yeah, so thinking and test setting.
Yeah, it's 90 and then the time doesn't show up.
90 minutes.
Yeah, but he changed it to 2 hours. Yeah.
Who out? Okay, I'm just being dramatic.
Okay, how was I doing because
You
guys
went-
remember what was I think it was you, right?
Or maybe assignments even, I honestly don't know. Yeah, I feel like this isn't it. I feel like you went to assignments.
Broke.
Oh, well, oh, this was, okay, and I think maybe click on there, and there you go.
Oh, God.
It's really not that bad though, because he only has, so everything that you see on like Blackboard,
Mm-hmm.
you basically don't pay attention to.
Okay.
Your grade book, don't pay attention to it.
The homework
Is what
stuff,
you see.
don't
The
pay
homework
attention
stuff
to.
on Pearson, don't pay attention to stuff.
Just
You
do
only
the
have to do
practice.
the practice test, and a module test.
Okay.
He made it a
Oh.
point to say it still might show up, cause he's not gonna go through and delete everything, but that is all you have to do and that's all that will affect you.
Okay.
Exactly.
The practice test is unlimited tries, but the module you only have 2.
Yeah.
Okay.
Yeah.
And leave, it is a good idea, in February, first time I did it, she was able to get to an A. If after, trying again the first test. So you try the first test, the first attempt is you son, at least one attempt you son. Your second attempt, your call. Before the end of the class, of course, before the grades are final.
So
She takes
last week was just the practice test or the pre-test?
And the test.
And the
Practice
test.
test and the test.
And
The
the
module
module.
test, you'll see it once you go on there, like
Yeah.
it'll literally say
Okay.
pre-test module 1 and then module 1 test.
Yeah, there are a lot of things here.
Okay.
And basically you say, bless you.
Do you have the book?
Huh?
Did you buy the book?
No, not yet.
So you need the access code
Okay.
in order to get into Pearson Meeting.
I probably need to go get my book.
Okay.
Yeah, so.
You can do it online, which is like 181, and then
In person is like 380.
Oh, I'm not paying $380 for a book. Not gonna happen. No.
Same thing.
I could do $180 though at the bookstore and then just use the code.
Well, no, the online one is 180.
$180.
So
Okay.
you use the link.
Okay.
Which is in.
Oh, got it. Okay.
And if you take your next math class right after this, you don't have to pay again, they use the same thing. they
Same
do the
book.
thing.
Oh, perfect. Okay.
So,
And they let you use the code again.
yeah.
Oh, nice. Okay. Dang, that
But
saves
there
a
is
lot of money.
time limit, like, there is a time limit, I think you have like.
It's like 80 something weeks for this one.
Okay.
I looked through it because I have Algebra Next, and it'll go to.
Oh, I have Algebra Next too.
Okay.
So,
So there's.
I think we all do.
Yeah.
okay.
And I'm gonna see you in physics too.
Yeah,
Ooh,
we're gonna be friends.
physics.
We're gonna be besties. I do have a question for you though.
Yeah.
Not even on this problem, but the
Hey, I'm in
exponents, since we
school.
were just talking about it. I've been screwing up because like it says -6 squared. I would think it's -6 times -6, which equals
It's my
positive.
computer broke.
But is it not that?
Okay.
You
So-
don't carry over the
beginning.
negative sign?
All right, the parentheses matter, okay, that's a good, okay, just go back a few minutes mentally.
My apologies.
Yeah, that's good, that's good. -3 inside the parentheses,
Hey.
that's equal to -27.
Okay,
Now, let's say I didn't have the parentheses, just for a second.
Yeah.
-3 to the power 3. All right, this time,
it's not weird.
this negative sign stays out, the first thing you do is 3 to the power 3, which is,
27.
27.
okay, these two are the same.
Okay.
How about this? Same thing.
That's 9.
You do 3's to the power 2 first.
Nine.
That's the first thing you do. 9. Now they are not the same.
Okay.
So, depends on the situation, the more examples you see, the more likely you'll get it right. So, 4 different takes. Here, I have the parentheses around -3. That's what, in general, if you have the parentheses around the base, it's the same base multiplied this many times. Yeah.
Will there ever be an instance where the exponent number at the top is negative?
Well, we won't, but it could be.
It could be.
Maybe an algebra.
We won't see it here.
Okay.
It won't show up in any of the questions,
Okay.
but it could be.
In the future, like in the
Not
next
in the,
class.
not in the, maybe in your next class, I
Okay,
don't know
yeah.
about it, but
You teach the next class too?
no.
Aww.
But he teaches physics. He does-
Okay.
I'll have
Yeah.
to-
Okay, that helps, sorry, thank you.
So have a look at this.
I'm gonna take a picture of that.
Just like we were thinking. Wait a second. you can
At
see-
school, guys.
I just realized that the four semifinals in the World Cup are Argentina, Spain, England, France. But the FIFA rankings are not
He loves soccer.
exactly accurate. I don't remember any other World Cup. I think these four teams are ranked 1, 2, 3, and 4 in the world ranking. The top, according to the FIFA rankings, the top 4 teams are in the semi-final.
So it's gonna be good.
Yeah. So Argentina is going to play against England, and France is going to play against Spain. That semi-final is almost like a flip. I mean, if they weren't in the same bracket, it would be no surprise that they meet in the final.
Yeah, so Spain has to beat what? France? And Argentina has to beat England, and then they can,
Then they meet in the finals, Argentina,
because
Spain.
even though the areas around each other, they're in different brackets.
Yeah.
Maybe you could explain something to me that I'm confused about. Like, why is dang it, I forgot his name. The soccer player, the best soccer
Messi?
player.
Messi.
Holland?
No,
With the blonde hair that everybody's talking
no.
about? Ronaldo?
Ronaldo. Like, why is he deciding to quit?
Ronaldo.
And what
He
is so
likes Messi.
sad about it? Like, I don't understand.
People are talking either Messi is number 1. I don't think Ronaldo is number 2. He's not number 3. He's not number 4. He's not number 5.
Right.
But he's 41.
He's 41.
He was old. I mean, there were
Like years
doubts.
old.
I can't even believe he doesn't look 41.
He's up on the old shit, first of all, at 40.
But he's old though. For running playing soccer like that, that's kind of old.
I'm sure medically he is really healthy.
Oh,
Right, yeah. But he's been playing a lot. But why is he quitting? Cause he's old. I just
Well, it's that he cannot complete a 90-minute game.
oh.
He cannot.
he's also like already kinda, like he has the status, he's probably got crap ton of money.
Yeah.
Yeah, he
You
does,
know,
he
I
does.
mean-
He doesn't need the money anymore, that's
Yeah,
for
he's-
sure.
He's about to be married, I think he's engaged,
Oh.
I think, so like probably just
So he's
selling
like, I'm
down.
done.
I'm
Yeah.
sorry for that later.
No.
Yeah. Okay.
I've seen some of his plays. At least when it comes to soccer, he is less than an honest player.
Mm.
Uh,
Messi's
No,
honest
no,
though.
like even then, he has a good chance that he's gonna get the penalty because he's fouled in the penalty area. He keeps on trying to score and he usually gets the penalty even after that, but he doesn't die. I've seen Ronaldo fake. Oh, there was I wish Ronaldo would get so many of those yellow cards again, Argentina versus Switzerland game. Minute 65 or 70. A Swiss player got a yellow card. And what was the reason? Cheating. He tried to deceive the referee. And the referee's first reaction was that he got fouled and he issued a yellow card. Then he checked it in the video assistant reference. He realized the Swiss player, Edmolo, dived, faked it, tried to look like he was fouled. Then it completely changed. The yellow card to the other player cancelled. Edmolo gets a yellow card, and because it's the second one, it's a red. And he goes out. It's perfectly fair. Right? If you try cheating, you should learn your lesson. Right? You are out of the game. You don't have a second chance. Before you prove, you learn your lesson. You have to pay a price first. He is out.
Mhm. I think it also just, they do, 'cause everybody.
So you grew up playing soccer.
Yeah, I played a lot.
You look like a soccer player though, for real. Like
Not
you
anymore,
slim.
Not anymore, and not anymore. So this one, If there is nothing in between the numbers, it's a multiplication. 18 times 2.5. We work with, this is nothing new from last week. We are working with decimals. Only one of the numbers is a decimal. The other one is just a whole number. So the way Pearson does it is, forget about the negative sign first, and then do this. There is a word for it, I think it's called long multiplication or something. Long multiplication.
You say forget about the decimal sign for now?
For the moment, it's not going to be the answer.
Right, okay.
Or do it in your head, this is important. If you want to do it in the Pearson way, I have to show it to you. So 18 times 25. All right. The way we do it is 5, we take this 5 first. 5 times 8, that's a 40. You put the 0 down, keep the 4 in your head. 5 times 1 is a 5, but that was a 4. It's a 9. Times 2, that 2 is actually a 20, right? So you are not multiplying by 2, you are multiplying by 20 in some sense. So first you multiply by 2 and then add a 0, or effectively, practically the same thing, shifted. 2 times 8, that's a 16, put the 6 down, 2 times 1, right? Then, now you are adding them. This is 18 times 5, and if you want to think about a 0 here, this is 18 times 20. If you add them, you are multiplying the same number first by 5 and then by 20 and then adding them. The whole result is the first number times 25. So 0, and then there is a word for it too, 9 times 6. 9 plus 6, 5.
Mm-hmm.
So 450, then you start thinking about the decimal part. If you are doing a multiplication, you count the total number of decimal digits in both of the numbers, right? How many in the first one, how many in the second one, together, how many?
1.
1, that's just 1. So you have one decimal digit here. Imagine a decimal dot here, if you have to. Move it this way, becomes 45.0, but 45.0 is really 45.
Mm-hmm.
The trailing zeros after a decimal dot make no difference. So this should be 45. Thinking about the easiest way to talk about this. First, let's get rid of the parentheses, okay? First, let's get rid of the parentheses. Negative 4, which question is this? 5. Negative 4 plus negative 6 plus 12. Well, this part here, plus a negative number, is the same as a negative 6. So you have negative 4, you have same thing if you have a chain of multiplications, additions, multiplications. If you have a chain of additions, that doesn't matter, but if you have a chain of multiplications, it does. Anyway, let's make it general. A chain, a sequence of additions and multiplications, left to right, because otherwise it makes a difference. Now, it would be different, a whole different story if you had the parentheses. You don't. In this case, left to right. So first you can think about it like this actually, and then like this, left to right. There are some other rules too. We'll see them in time. Negative Negative 4 minus 6, again,
Negative 2?
-10.
negative 10.
Negative 10?
Oh, yeah, so,
How we get negative? Oh, yes, okay, because you add them together.
so you start with the negative 4, you move to the left 6 more.
Got it,
You move left 6 more, negative 10.
got it. Okay.
Negative 10 plus 12. You move to the right, 12 more. You move to the right, 12 more. After moving 10 units to the right, I'm already at 0. I need to go 2 more.
2.
That leaves me with a positive 2. All right. Okay. Most of this we have done last week. However, everything we were doing last week were with positive numbers. Here, you have a negative fraction or decimal or whatever, something negative, negative 3 over 16, right? And let me zoom in a little bit. This is a division. The second number is also negative. Right? If you multiply two negative numbers or if you divide two negative numbers, the result is positive. So, for this question, these negative signs, forget about them. I'm not generally saying that negative signs don't matter. For this one, 6. Negative 3 over 16 divided by, inside the parentheses, negative 1 over 4 is really the same as the same operation, is really the same as the operation without the negative signs. All right. From last week, how Pearson way, or do it in your head, like that, that's 3/4. Anyway, Pearson way, turn the multiplication into a division. I mean, turn the division into a multiplication. This was division. But flip the second one. And when I say flip, that's another word I learned from you. Switch the top and bottom number.
Okay, so multiply and
4 over 1
flip.
and 3 over 16, but 4 over 1 is the same as the 4, doesn't matter, so
Okay,
I'm just going to erase that 4. Erase that 4. And then for this question, it doesn't make too much of a difference, but I would suggest that it's a little bit different from the Pearson way. Instead of multiplying across 3 times 4, and doesn't matter too much here, but it can matter in some other problem. Try to look for a cancellation. There's a 4 here, and there's a 16 at the bottom. There are 4 4s, and the result just becomes a 3 over 4. Yeah, this is division.
okay, so, can you do that one more time? I got the part where you flipped it, but like,
Okay.
I'm sorry.
No. Please don't say sorry.
Okay.
I'll ask these questions. That's what we are here for. Times the 4, I ignore the 4 over 1.
Right,
16, I'm sorry. Pearson way of doing this, if you are multiplying two fractions, or this can be considered as a fraction too, multiply across as you call it, multiply the numbers at the top, it goes to the top of the answer.
Right? Got
And-
it.
But there is this part here in blue. Simplify your answer.
Okay.
That simplify means your final answer, if it's a fraction, should have its numerator, and numerator is the number at the top, denominator is the number at the bottom.
Right.
These numbers should be as small as possible.
Okay, got it.
Of course, it should mathematically be the same number, and it will stay as the same number, as long as you divide the numerator and the denominator by the same number.
3
It
over
stays the
4.
same. 12 parts, anything that you divide into 16,
Right.
and then take 12 of it, that's exactly 3/4 of the same thing. Because 12 is 3/4 of, we will see more examples.
I get it now.
3 times 4 the 12.
Right.
But I would say, in the future, in some questions, when simplification is not as easy as this,
Right.
or easy but not obvious. Try to look for a cancellation before this.
I get it.
And then it just becomes.
Oh, so do you think that we should wait? You said try to simplify it before you get to the last step, or?
It can make your life a little easier, because
Okay.
we have seen a couple questions last week where the number here, is it divisible by 11? Is it divisible by 17? No, you don't even go to 11, like maybe, is it divisible by 3, 4, 5, 6? There are some divisibility rules, I'll mention them in time, or you can figure them out yourself, it's not in time.
Right. I probably will do it that way.
Simplifying may involve large numbers here. To avoid it, you can, before this step, you can look for a cancellation.
Okay.
In this case, it's not hard. 12 over 16 is not good.
I got it.
What the, oh. Another vocab word, as you call it, combining like terms. If you look at the expression, the variables you see, x and y, if they have different symbols, you have to treat them as unlike terms. Which terms are like terms here? The ones with x in it are like each other, and the ones with y in it are like each other. And also x and y are both, it's not like one of them is an x, the other one is an x squared. Still they would be different. In this case, you don't have an x squared, x cubed, whatever. So 1.5x minus 3.1y minus 5.4y. When it says combine like terms, it's asking you to put this and this together. So what do they make?
It would be it'll be 5x.
If this were a plus, you are
Oh.
right. 1.5 plus,
So it's 2.
But wouldn't you?
No,
Negative.
it's-
Wouldn't you cancel
negative.
Negative 2.
So
Oh my
what
God.
you are doing here is actually 1.5 minus 3.5,
Wait, what?
Keep change opposite.
and then, keep changing. That becomes, however you do it, negative 2.
Negative 2. Okay, got it.
So I have a -2, but don't forget, -2x.
Negative 2x, got it. Okay.
Right, so how about this?
Negative 3.1y
Negative
and
3.
negative, oh, I know that one is negative 8.5.
Negative
Y.
8.5.
Yeah, negative 0.5 y, yeah.
Negative 8.5. Why? Have a look at this. This is one of the easy problems, but
That's the answer.
yeah, that's the answer.
Okay. That was easy.
Yeah, it should be easy, but I was seeing a number of more than I was expecting,
Mm-hmm.
who make a plus mistake, minus mistake, and I can see it because it's very easy to make a careless mistake.
Yeah.
You know, I would probably be making them more often than you. Find a way to stay focused, otherwise it's really not that hard. Have a look at this again, go through the steps mentally, pluses, minuses, and things like that.
And you just keep changing opposite.
Okay. If it works for you, you're going to do the same thing too.
I'm confused.
Seven. Okay. Now, maybe Joanna's thing can be useful here too. I don't, let me show you.
Absolutely.
Yeah, let me show you how I would go about this. So, if that negative sign were not there, right? We know how to do it from last week. I'm adding two fractions, but they don't have a common denominator. I need to bring them to a common denominator. But just like if you divide
Yeah.
both the numerator and the denominator by the same number, it stays the same.
Okay.
If you multiply the numerator and the denominator, it stays the same too. This 5/9, right, is the same as, so you tell me, I'm going to multiply the top number and the bottom number by 4. Sometimes, I could actually do it. Sometimes, this number at the parentheses under a fraction, it means I'm multiplying the top, you don't have to do it, I don't know. I'm multiplying the top number and the bottom number by 4.
Okay.
Where does this 4 come from? You'll see in a second.
That's what I was just about to say. Okay.
5 times 4,
20,
9 times 4.
36.
Oh, the second fraction is a 1/6. This time let's try to do the same thing with a 6. 1 times 6,
6,
6 times 6.
36.
5/9 is really the same as 20/36. And 1/6 is really the same as 6/36. They are exactly the same mathematically, equal to each other. What I have done here is,
Can I ask a question?
yeah,
Wouldn't you use the least common denominator on this one?
actually, you are right. You can use an 18. Why did I not think about it? You are right. You can use an 18. Let's correct it before it's too. Least common denominator. I don't know why. You are right. Say,
Bless you.
say
Bless you.
we do the same thing with the 2 and a 3. Right? It's going to be the same thing. Actually, this wasn't exactly a complete waste of time. We will do it again and again. If you take a fraction and multiply it by any number, both the top and at the bottom, it stays the same. All right, so 5 times 2, 10. 9 times 2,
18.
18. 1 times 3, 3. 6 times 3, 8. Yeah.
Alright,
Yeah.
but it's not on this. So, should I not ask it?
Go ahead.
So, I have an equation, right? 7 plus 6 divided by 2 times 3 minus 5. No parentheses. yeah. No parentheses.
Okay, you do the division first.
But why? It says it PEMDAS,
Okay, so,
multiplication. Then division, then adding and subtracting.
but there is no multiplication here.
But there is, 2 times 3.
Oh, 2 times 3.
Yeah.
Then you do the,
Right.
actually, even in that case, this whole thing becomes an expression of its own between multiplication and division. You go from left to right, so that would be 26 divided by 2, 13, times the 3, 29, and then 7 plus 29 minus 5.
Okay, because I was doing the multiplication first, and that led me to do 2 times
If there
3.
were parentheses here, yes. But if there, between multiplication and division, there is no hierarchy,
Okay,
unless there is parentheses.
okay. Thank you.
Back to this question, negative 5 over 9 plus 1 over 6. 5, I forgot about the negative sign. First, 5 over 9 is the same as 10 over 18. But there's a minus sign. There's a negative sign. You have to take that into account, right? minus, right?
So it'd be negative 10 plus 3 would be
So-
negative 7.
So this thing becomes negative 5 over 9 plus 1 over 6, which is negative 10 over 18 plus 3 over 18.
Which is
Is this your way?
Pearson way.
Oh, the Pearson way. I like your way.
Do it however you want. But I need to show you how they do it.
Okay,
Well, if you are doing an addition or a subtraction, or you don't have to do this for multiplication and division, but if you are doing an addition or a subtraction with fractions, you need to first bring them, Pearson says, to a common denominator, which you can. After you do that and choose the least common, anything here, as long as it's a common factor, would work, but to make your life easier, choose the smallest one, least common. I've done that. That 18 is going to be here too. And then
10 minus 3.
And then you do the operation with the numbers at the top, which is
Negative
that becomes a negative 7 over 18. And that negative sign, it could be at the top, or it could be at the bottom, but what it wants you to do is to put it here. Okay, one last thing. Can I simplify this? No. So this should be negative 7 over 8.
okay. Got it.
Okay, I have parentheses here. 5 plus 5 times, and the parentheses start. Inside the parentheses, 4 plus 3 minus 6. Okay, so I can maybe type it here. So 5, this is equal to 5 plus 5. What's the stuff inside the parentheses? First you deal with the parentheses. Clear, there is an explicit parentheses. That's what you deal with first.
Is that 4 plus 3 in the parentheses?
4 plus 3.
Okay.
So 4 plus 3 minus 6, which is just 1. So this is 5 times 1, if you want to think about it like that. There is nothing between the 5 and the parentheses, you can think it to be a multiplication. So this is 5 times 1, which is nothing but 5. What is it? 5 plus 1.
Right, okay.
5
yeah,
times 1, that 1 comes from the parentheses, times the 5 right before the parentheses, another 5, and there was already a 5 plus, so 5 plus 5, which is one more question. Okay, there is another word for this too, distributing. Actually, here we did that distribution. We distributed that 5 actually. We didn't, but we could have, and the result. So this is one of those questions. Nine minus 7 x minus 4y. Plus 9 7x plus y. That's what you need to do. The way I like to go about it, when you have nested parentheses, I mean you have these square brackets or they are kind of parentheses, it just tells you the open, the symbol, you see the difference in the shape, it tells you the opening and closing. They go, okay. So for this part, opening and closing, opening and closing. From inside out, if you have nested parentheses, go from inside out.
I think I know how to do this.
So I'm going to first deal with this parenthesis. I'm going to try to get rid of it. And there is a negative 7 over there. So this one, just keep the shape. You can change it as long as the opening and closing is clear. Let's keep the same shape. 9 minus what do I do? Or let's not say minus. This is a minus 7 or a negative 7. Negative 7 times x. And then a
Times
negative and a
6.
negative. Where is that plus? Where does the plus come from? 7 times 4. I mean, I'm sorry, guys.
I'm confused.
Negative times negative.
Is a positive. Got it.
Positive, and then 2 is.
Okay, yes, so that's positive 28y.
And that's the y term. I do the same thing here. That's already a plus, right? Plus 63x plus 9.
9. Got it, yeah.
These don't matter anymore, and it's just like the stuff that we are doing here. 9, and there is nothing to combine, that's a 9. Why don't you combine the x terms here and here? Negative 7 and positive 63. Negative 7 and positive 63. 3x, right? Plus 28 and a plus
Okay.
9.
Okay.
Plus 32y.
Plus 32y, okay.
I think this thing is picky about how you type your answers. Right? It's comparing text to text. This is correct, but the way it wants, the format that it wants to put your answers in, x first, y second,
Okay.
and then the constant.
Okay. Okay.
Yeah.
Can you pick me up on how you got 32? Because 28 plus 4 is 32.
28 plus 9 is not 32.
It's an arcane, I put it in
It's really something at the back of my mind. Still. Hey.
Yes, I'm here.
Okay.
I'm
Yeah,
here.
correct.
I was getting ready to drop you.
You no,
I would
don't.
almost say no, yeah, she's here.
Perfect.
I made it.
Love the back.
Thank you. Thank you for checking on me, though. I appreciate
Absolutely,
it.
Yeah.
Thank you.
Good choice.
Thank you, Leila. The purple number, 28 plus 9, it's not a 32, it's a 37. Well, I'm not sure how good of an idea it is, but maybe it's something is going on between me and my family. Every time I think it comes in a verse, I'm wrong. It's getting like, well, out.
Like if she ain't here today, that's it.
Just realize something about some. I'm not fast at processing indirect conversations. Say it. Don't imply it, say it. While I was doing that, I just remembered something that I heard another indirect communication. Now I'm realizing what it actually means. So that's what just happened a second ago. But thank you for following what's going on. That's a 37, and we need to change this to then, right? We need 37, right? And actually, shall we try? I don't know, but I'm pretty sure. Let's keep safe. What was working before? While we are typing 56X. 7, right? And they are both plus, right? Are they plus? Yes. 9 is a plus 2, right? There is only one. Okay. That's the question Joanne asked a second ago. Let's do this one too, and then take another tea break. So let's get it right.
Okay.
Yes. Wait, what? Oh, no, it's, well, yeah, it's 6 plus 60 divided by 5.
Okay.
Times 2 minus 8.
Oh.
Okay, thank you.
So let me rewrite it
Okay.
a little bit more zoomed in. So this thing that I saw on Giovanna's paper, I heard it from you guys again. Those mnemonics, pandas, as you call it. It's not a complete thing. There are more general rules, but the pandas, let's put it there. I can't think I'm doing this. Parentheses, exponents, multiplication, division, addition, subtraction.
Okay.
But it may be misleading when there are no parentheses and you see a chain of multiplication and divisions without parentheses and a chain of addition and subtraction without parentheses. That's the case here. So let's write it again. 6 plus
Okay.
60 divided by 5 times 2 and then what?
Minus 8.
Okay, I know that this is the stuff that I need to deal with first.
Okay.
But it's still not exactly clear from pandas. Now what do? Do I do 60 divided by 5, which is 12, right? 60, which is 12 times 2. Or 5 times 2 is a 10. Do I do 60 divided by?
You
Which
would
one do I
do,
60 divided by 10.
no,
Yeah, because you have to do the multiplication before the division.
it's 5.
But
Because-
you don't, again, but if you have a chain of multiplication and division without parentheses,
You do the multiplication first.
Oh, it doesn't matter?
left to right again.
Not to right. Okay.
Oh, so 60 divided by 5.
Yeah, 'cause
Oh,
my problem
oh.
is if I- if I
But,
multiply
okay,
it, it would
but
come out
That's
It's
one you
PEMDAS.
need to do.
Doesn't make any sense.
So that's parentheses,
I did this question.
exponents,
When I
Yeah.
got this
multiplication
one.
is before division.
The other problem I had was why
That's
it
if,
was,
so
it was
let's,
uneven.
okay, I'm gonna change this PEMDAS, right? I'm gonna.
Oh, I like it. I like
Cross it
PEMDAS.
out at
Let's do
this-
it like
No,
that.
don't
at
change.
this
Right.
point.
Multiplication and division comes before addition and subtraction. But between multiplication and division, there is no hierarchy,
Okay.
unless there are parentheses.
Just left to right.
So no.
Oh, okay, okay. So
No.
because the division one was on the left, then you do that first.
If you had these parentheses here, what would happen? Then parentheses
that.
comes first, it will be 60 divided by 10. But without the parentheses, left to right.
So if there's no parentheses in the equation, you do not follow PEMDAS.
No, you go left to right, okay.
Yeah,
Between
basically.
between multiplication and division, you go from left to right. Between addition and subtraction, you go from left to right. But other than that, always, an
Okay.
addition or a multiplication always comes I mean, a multiplication or a division always comes from before an addition or a subtraction.
So this would be 60 divided by 5 is 12 times 2, 24.
2 and a 4, so
Plus
that's
6 is 30,
right?
and then so on until you get 22 for an answer.
Mhm.
30
30
minus 8 is 22.
Okay. Got it.
And here also, the answer doesn't depend on left to right here, but if it were to, you do between addition and subtraction, there is no hierarchy. You go from left to right. So let's go over the steps again in your head. Let me know if issues. It's not this one, in this case, it's not this. Because there are no parentheses. That's a plain.
I am, yeah, sorry.
It sounds like the times on like my dream catcher that
I
I have.
have everything off and it's still coming through. I'm so sorry.
I said, maybe because you're overwhelmed and not like this.
No, it's the watch. I have it off, but I keep trying to,
Oh, okay.
yeah.
It's an easy one. I got to change this and the other one.
So like this is one of the modules that's required for our grade right here? What he's going over with us?
Yes, but you'd do it like on your own.
Technically, he's supposed
Yeah.
to, okay.
But he goes over these because normally, like, it's not gonna be the same exact question with like numbers.
Okay,
But the first problem will likely be almost exact, like, what, I think the first problem on his was absolute value, so on yours, it'll be absolute value.
oh, got it,
You know
okay.
what I'm saying? So you
Yeah.
like, just follow through, and basically the entire time, he just goes over through practice tests, because that's exactly what we're doing. And then modular test is the same thing, it's just different
Got it.
grade. And you get less tries on the modular test.
Okay.
Yeah.
That next problem looked pretty easy. Like, I almost could do some of these in my head. Almost. I don't want to get too ambitious, but
What was the last problem?
it was like negative something divided by a regular number. Like,
Oh, okay.
that's like very easy. I know the next class probably gonna be a little difficult, so I'm enjoying this.
Honestly, I was always better at algebra, but the long division, stupid fractions, always get me every time.
Yeah.
Every time. Cause I never wanted to work it out. That's annoying.
So that's addition?
Oh yeah, see, this is easy. Negative 7 to 7 divided by 169.
No,
That's plus.
Oh, that's a plus
Yeah.
sign.
Mhm.
Wow.
It's really, it's annoying very,
Okay.
every time.
I mean, that's like kindergarten.
It's actually so much worse than I was thinking. I,
Positive 92.
I'm just gonna take it wrong for like 4.
I have no idea how it can be fixed. This one, again, addition, we have done it a gazillion times last week. But you have one of the numbers negative. The first one, negative 77 plus 169. That's not 8, but what is the negative 77 plus 169, right? But most people keep putting their equal signs in a row. I'm gonna rewrite this because maybe it makes it clearer to you. So this negative, the way I like to think about it is, there are many ways to think about it. This is really no different than this. Is it 7?
Yeah.
It's really no different than this. Or what you start with, to the right,
169.
Right. Yeah.
so after 77, to the right, you are at 0. And whatever is left out of 169, after you use 77, that much to the right,
Yes.
which is plus, or don't put the plus, 92.
92. That is pretty easy.
And this stuff, like, after you do this, you can think of it as this, and from last week, borrowing, carrying over, and all that stuff, whatever, that's gonna be 92, right?
Yes.
So that's 16. Let's go. The thing is,
Do we get a break?
huh?
Do we get a break?
Oh, yeah, do you guys want a 5-minute break?
Well,
Yeah, let's take a 5-minute break. Yeah, I
okay,
need to
because
clean
my
mouth.
laptop broke.
Let's take, and during the class, guys, you don't have to ask them, unless you are abusing it, of course.
Okay,
Get
I have to.
out, pick up the call, or, I don't know.
I'll be right back. I just need to. My laptop broke, so I'm gonna go and get my
shoot,
other
I forgot
one.
again, it's wrong.
What
You
happened?
forgot to punch in?
No, I forgot to bring my computer here because on Friday I heard that there is someone that helped me out. I'm horrible at remembering stuff.
You could say, "Hey Siri, remind me to." You have an iPhone?
No, I
Oh.
remember it.
I think you can still set up reminders.
Yeah, of course.
Yeah. Okay, I'll be right back. I promise. I won't be gone for a long time. I just want to get my other laptop so I can make sure that I can keep up with the assignments. I'll be back. Which way out? I think it's this way. I'm gonna be putting y'all in timeout because some of y'all was being very bad while I was in class. So wait till I get in the car. Wait till I get in the car. Cause some of y'all was being very naughty when I was in there. Like, oh, wait till I get in the car. I got something to say. Some of y'all were being good, but wow, some of y'all was being bad. Wait till I get in the car. You still have a friend? Hey, Charles. Hey, Cena. I love you guys too. My freaking laptop broke, like, ugh. And then when I try to like turn it on, it's like giving me some strange message. Like, I don't got time for all that. Like, I could be getting work done and I can't even do nothing. So I just gotta go back home. Angel Reese. Really? You gotta look like Angel Reese. The amount of times of people that tell me that I look like Angel Reese, it's like a